Alright, so in this lesson we're going to start moving beyond solving systems by graphing and start looking at one of the two other ways of solving a linear system. But just first off as a warm-up, just to, because it's been a couple days, see if we can remember how to solve a system by graphing. So there's two equations here. I'd like you to take a minute and try and plot them using the method of your choice and see if you can find the solution for the point of intersection. Okay, so take a minute to do that and push play and ready to go through the answer. Okay, so just to recap through this quickly, the first equation is already in slope-intercept form. So this one has a slope of 1 and a y-intercept of -1. So from y-intercept of -1, for a slope of 1, I go up 1 over 1 to the right, up 1 over 1 to the right, and so on and so forth. That gives me the first one right here, the red line. The second one here, I put it in slope-intercept form. I rearranged the equation to get y by itself. I subtracted 2x from both sides of the equation to get to this line right here. And then I had negative y equals negative 2x plus 3. So to get positive y, I divide every single term by -1. So that changed the sign and everything. So I wound up getting y equals 2x minus 3. So starting from y-intercept of -3, I went up 2 over 1 to the right, up 2 over 1 to the right, and so on and so forth. When I graphed both my lines, I saw my point of intersection was right here at the point 2, 1. Okay, so that's my POI, which means the solution to this linear system is that x equals 2 and y equals 1. Okay, that'll be my solution. Okay, so we're going to look at this exact same problem another way once we look at, again, a new method of solving. Before we get into that, though, I'm looking at two different situations here. So we got a situation here and another situation here. So each one's a linear system. And what I want you to do in each case, take a look at both equations, choose an equation, and isolate one variable. And it can be either x or y, and it can be whatever equation you want. So choose any equation in each set, choose any variable x or y, and isolate the variable. So before you get into that, I just want you to think ahead. Look at both equations and think what would be the easiest variable to isolate for in either of the two equations. So you're trying to make your life easier here. So look at what you find easier, isolate that, and push play and go through the answers together. Okay, so hopefully if you're looking at the two equations on the left here, you'll notice here that the easiest variable to isolate for is actually in the second equation, not the first one. And it's going to be this one right here, the variable y in the second equation. The reason being, now it has a -1 attached to it, but it doesn't have value larger than that attached to it, which means that when you go to isolate, you don't have to divide by anything that's going to introduce fractions. So it makes it a little bit easier, and you have nicer numbers to deal with. Isolating for x up here, you have to divide everything by 5 eventually. Here, divide everything by 2 eventually. Here, divide by 4. Here, you're not going to have to divide by anything other than a negative. So this one's a lot easier to work with. So what I'm going to do here is I'm going to subtract 4x from both sides. Okay, so that's going to give me negative y equals negative 4x minus 9. Okay, and then I'm going to divide by -1, just like I did on the first slide there. That's going to give me y equals positive 4x plus 9, because all those negatives cancel there and there. Okay, so again, this is by far the much easier choice. If you look at the second group of equations, you can see very quickly, hopefully, that the easiest one to isolate for is the x variable in the first equation. So in this particular one, to isolate for x, all I need to do is move the 6y over by subtracting it from both sides. Okay, so I'm going to get x equals negative 17 minus 6y, or you can write it as minus 6y minus 17, whichever one works. Okay, so again, all we've done is we've isolated for one of the variables in one of the two equations. Okay, and the reason we're doing that is because now if we go back to the first example, we can do the exact same thing algebraically we did in the warm-up, because if we isolate for variables, we can actually then put the two equations together to solve. So what I mean is, if you remember looking at a graph, remember what we're looking for is the point that satisfies both equations. So that means that x equals 2, y equals 1 will be a point that works in both of the two given equations. So what I'm going to do here, with the two equations given, these are the exact same two equations we used in the warm-up. I have y equals x minus 1 and 2x minus y equals 3. Well, looking at the very first equation where I know that y is equal to x minus 1, well, by combining the equations, I can replace the y in the other equation because I know that it's equal to x minus 1. And again, I don't know what x and y are, but I know that whatever x is, if you subtract 1 from it, you get y. So what I'm going to do here now, again, this is where the word substitution comes in. I'm going to substitute the x minus 1 into the y value in the other equation. So when I do that, everywhere I see a y in the equation, it gets replaced by x minus 1. So now looking at this equation, the letter y is gone. We've now replaced it with the information from the equation 1. And the best part of this is now looking at this equation, there's only one variable in it. We only have x's. So, and an equation that only has one variable in it is something that we can solve. We did a lot of that back in grade 9 and a little bit at the start of this year. So once we have this here, we can actually solve this equation because there's only one variable in it. So from here, solving further, I'm going to have 2x. Distributing the negative 1 through the brackets, I'll have 2x minus x plus 1 equals 3. Okay, I'm going to combine my like terms. 2x minus x is x. Then I wind up with x equals 2. Okay, so now that I've solved that equation, I have my x value. I still need to find my y value. Well, if I go back to one of the original equations, I can use this. If I know x, I can find y in either of the two equations. So I'm going to choose this equation. It's a little bit easier to work with. I'm going to sub x equals 2 into the first equation. So I'm going to have y equals x minus 1. So now it's going to be y equals 2 minus 1, which gives me y equals 1. Okay, so again, I get the exact same solution I did when I did it by graphing, x equals 2, y equals 1. So the whole idea here is, if we have a variable isolated, we know the relationship then between the two variables, and we can substitute that information into the other equation to create an equation that we can actually work with and solve. Okay, so it seems like a lot's going on here at once, but again, this is a very consistent process, and we'll work through a few more together to see that we're on the right track. Before we do that, let's just summarize the steps we're going to use to solve a system using this process called substitution. So the first thing you're going to do is isolate x or y in one of the two equations. So that's what we did back on this slide right here as practice. We didn't have to do it in this example right here because we already had a variable isolated, right? We already had y by itself, so that part was already done for us. If it wasn't, though, we'd have to get a variable by itself. Okay, and again, make your life easier. Find the variable that looks the easiest to isolate and do that one. Okay, once that variable is isolated, what we then do is substitute that information into the other equation, the one you haven't touched yet, and replace that variable. So that would be this step right here where we took the y equals x minus 1 and replaced the y in the other equation with that information, the x minus 1. Okay, once that's replaced, now the equation that's left over should only have one variable in it. You can solve it just like you would have done using algebra back from grade 9. Once you solve that, you now have one variable solved. You can sub the answer back into one of the original two equations to solve for the other variable. Okay. Once you have both variables, you're basically done. You have your point of intersection, you have your solution, but it's never a bad idea to check your answer by putting your final POI into both equations and seeing that left side equals right side. Okay, so this is the general set of steps that you can follow to use substitution, and in theory, it should work every single time. Okay, so with that in mind, let's try and apply that to more examples. So here's one. It says solve each of the following. We've got y equals 3 over 4x plus 1 and y equals negative 1 over 2x minus 4. Okay, so before we get into using our new method of substitution, I'm just going to quickly show you the solution on a graph. Okay, I know you guys can graph these on your own, but just for the sake of speeding things up, let's put them both on here. You can see that the intersection point is going to be down here at negative 4, negative 2, so we have an idea where the answer is going to be, but let's figure out how we can solve this algebraically. Let me just, for some space, get rid of this graph. Okay, so we'll go through this whole one together because this is the first time one we've really done completely on our own. Now, again, going through our steps here, it says the first thing we want to do is isolate x or y in one of the two equations. Now, it appears that not only in one equation, but in both equations, that step's already done for us. We already have a variable isolated, in this case, y, in both of them. So we only need it in one, but it is the case in both of them. So that step's already done. So now we can go back and say, okay, substitute the information, and that's the information from the isolated variable, into the unchanged equation. You are replacing the variable. So what this means here is that I take a look at my first equation. I know that y is equal to 3 over 4x plus 1. Since I know y equals 3 over 4x plus 1, I'm going to replace the y in the other equation with that information. So everywhere I see a y, it's now becoming 3 over 4x plus 1. So I'm going to do that. This is the substitution step. This is the big one. So y becomes 3 over 4x plus 1. And the rest of the equation remains unchanged. I still have negative 1 over 2x minus 4. Okay, so, and again, the best part of this equation now, if you look at it, there's no y's in it anymore, it's all x's. I should, in theory, be able to solve this using grade 9 algebra. I know there's fractions involved, so it becomes a little bit trickier, but it will still work. So from at this point now, remember going back to our steps, we solve like a normal run-of-the-mill linear equation from grade 9. So, oops, wrong direction. So let's solve this one for x. I'm going to collect all my x's together and all my constants together as well. So I'm going to move the half x over to the left side by adding it. And I'm also going to move the 1 here over there side by subtracting. I'm going to do both of those in one step just to save some space. So that's going to give me 3 over 4x plus 1 over 2x. And here I'm going to have negative 4 minus 1, which is negative 5. Okay. Remember to deal with fractions. A couple things you can do. If you like, you can multiply everything by a common denominator to get rid of all the fractions. But adding fractions is something we should be able to do as well. So I'll do 3/4 plus 1/2. So I have to find a common denominator. So 1/2 becomes 2 over 4. Okay, so this gives me together 5 over 4x equals negative 5. Okay, so at this point I'm almost done. For x, I'm going to multiply, I have a 4 in the denominator, so I'm going to multiply both sides of the equation by 4. So I'm going to have 5x over here, negative 5 times 4 is negative 20. Okay, and now I'm going to divide both sides of the equation by 5. So that gives me an x value of negative 4, which is what I saw when I had the graph out earlier anyways. Okay, so after I did that algebra, I now have x by itself. I know x equals to negative 4. So looks like I've done a lot of work here. I've done the hard part. I figured out one of the variables is equal to. What a lot of people forget is that the solution to a linear system is a point of intersection, right? It has both an x value and a y value. We've only found one of the two values. So remember, we have to go now sub our answer back into either of the two original equations to solve the other variable. Okay, so you can use either one of these two equations you like. I personally am going to choose this one. I think it's easier to work with because there's no negatives hanging around. So I'm going to take that equation, bring it down here, and I'm going to substitute that value for x into here. So I get 3 over 4, x is now negative 4, plus 1. And again, now it's just a matter of working through and simplifying. So 3 over 4 times negative 4, the 4's cancel here, you're going to be left with negative 3 plus 1, which is negative 2. Okay, so x equals negative 4, y equals negative 2 becomes our solution. Okay, so far so good. Let's take a look at another one. So in this situation here, again, we have two different equations with two unknowns to the linear system. I want you to try and solve this one. So what I'm going to suggest you do, you'll notice here that in this particular case, none of the variables are isolated. So you have to choose one of the equations to isolate one of the variables. I'd probably suggest at first glance that the first equation is far, far easier to work with. So I would actually use that one to isolate a variable, and you can probably see which one would be easier to isolate for, x or y, probably the x. I would also simplify the second equation as well. Expand through the brackets, distribute the values through the brackets, simplify as much as you can so you have an easier equation to work with. So I'm going to let you do that. I'm going to have you, again, simplify the second equation, pick one of the equations to isolate a variable, and we're going to solve this in part 2 of the lessons in the next video. But do give it a try on your own first, see how far you can get, and we'll go through it together over there. Okay? So we'll see you in part 2 of the lesson, and hopefully you make some good progress.